Hey everyone, here's the warm-up for our lesson 4.05, antiderivatives. And I know what you're thinking, antiderivatives? We just got finished learning how to take a derivative and now you want us to take an antiderivative? It's actually pretty cool, but before we do that, let's go ahead and get into these practice problems to get your mind moving a little bit. So for number one, it gives us the function f. It says f of x is equal to 40x plus 2x squared. This is a pretty easy problem, I think. It says, on what interval is f decreasing? So if you think back, f is decreasing when f prime is negative. So there's our justification for that. Let me go ahead and write that off. Let me go ahead and write that down. F is decreasing when f prime is negative. Okay, so that's what we're looking for. Well, how do we know when f prime is negative? Well, we have to figure out what f prime is first. So f prime of x is equal to 40 plus 4x. And then we have to figure out when f prime is negative. Well, there's a couple ways of looking at this. The most efficient way, the one that encompasses all different types of functions, and the most convenient method for me is to figure out when f prime is 0, does not exist, figure out any place where f prime might change signs. So we're going to go ahead and set f prime equal to 0 and solve this equation. So we end up with negative 4x equals 40. And so x ends up being negative 10. And so we would also look for when f prime does not exist and then compare there. But f prime always exists because it's linear. F is a parabola. So when x equals negative 10, we know that f prime is equal to 0 at that point. And so we're going to plug in some values for x that are less than negative 10. So we'll plug in maybe negative 1,000. We can plug in any value less than negative 10. The sign of f prime will be the same throughout that whole interval. So when I plug in negative 1,000 to f prime, I end up with a negative value here. And then if I plug in any value greater than negative 10, like 0 or 17 or 38, whatever it is, if I plug in x equals 0, that's probably the easiest one, we end up with positive values to the right of negative 10. And so now we can conclude based on this, if f prime is negative, f is going to be decreasing, and if f prime is positive, f is going to be increasing. So that's what's happening with the f function. So we can conclude now that f is decreasing over the interval negative infinity less than x less than or equal to negative 10, since f prime is negative over this interval. Okay, so there's our answer for number one. Let's go ahead and take a look at number two. Number two is a little bit more complicated, but not really in the sense of calculus, I wouldn't think, but more in the sense of just basic solving equations in algebra. And for whatever reason, that's where we tend to have our issues. The calculus tends to be pretty easy after it's all said and done, but we get hung up on algebra. So anyways, number two, it says there's a function, f of x equals natural log of 3x plus 5. Let's go ahead and write that down. F of x is equal to the natural log of 3x plus 5. Now, whatever that function looks like, it's going to be a logarithmic function, so it's going to look something like this, right? But whatever that function looks like, it's saying that we have 2 points on that graph, at x equals negative 1 at 3. We are looking for where the tangent line of that graph is parallel to the line, the secant line formed by those 2 points. So to give just an idea of what's going on here, we do have shifts and things going on. I don't want to dwell too much on that, but we have a graph that looks something like this, okay? A logarithmic graph. Now we have 2 points, negative 1 and 3. So let's say this is our negative 1 and let's say this is our 3, okay? So those are the 2 points we're looking at here. And it says that there's a secant line that runs through those 2 points. Something that looks like this. That's our secant line. We are looking for a tangent line that is parallel to that secant line. Well, parallel would be at a point in between those points, somewhere, not necessarily exactly in between, but somewhere between. And so we're looking for the point that produces a tangent line that's parallel to the secant line. Now, if you remember, this is the mean value theorem at play. The mean value theorem says that if a function is continuous over a closed interval and differentiable over that same open interval, then the average slope will be equal to the slope of the tangent line for some value between those 2 points. Well, this function is continuous over the closed interval -1 to 3, and it is differentiable over that same open interval. So what we're saying is the mean value theorem applies. Therefore, we know that f prime of x is going to equal the average slope over this interval, -1 to 3 for some value, and that's exactly what we're looking for here. So the first thing we want to do is take f prime of x. Well, f prime of x is, well, the derivative of natural log of something is 1 over that something, so it's 1 over 3x plus 5, and then we have to apply the chain rule, so it'll be times the derivative of the inside thing, so the derivative of 3x plus 5 is just 3. So then we can conclude that f prime of x is equal to 3 over 3x plus 5. Okay, so now we know the derivative. We have to now figure out the average slope in the interval -1 to 3. Well, how do we find the average slope? The average slope is equal to f of 3 minus f of -1 all over 3 minus -1. Okay, and then we can plug in values there, and this is where the algebra gets kind of gross. F of 3, if I plug in 3 here, f of 3 is going to be the natural log of 3 times 3 plus 5. Well, 3 times 3 is 9, plus 5 is 14. So we end up with a natural log of 14. F of 3 is the natural log of 14. Okay? Minus f of -1. So if I plug in -1 here, 3 times -1 is -3. -3 plus 5 is 2. So we end up with the natural log of 2 on the top there. And then on the bottom, 3 minus -1 is just 4. Okay? Now, that is the average slope. Now, we can figure that out. We can type that into our calculator and get a decimal value. Natural log of 14 is just a number. Natural log of 2 is just a number. But I want to work through this using some of our old algebra skills because we have some skills that deal with the natural log minus a natural log. So then we would say f prime of x, which is equal to 3 over 3x plus 5, is equal to the average slope. So let me put that in here. 3 over 3x plus 5. The derivative is equal to the average slope. The slope of the tangent line is the same as the slope of the secant line. Because they are the same, that would imply that those two lines are parallel to each other, and that's what we're looking for. So we end up with 3 over 3x plus 5 is equal to natural log of 14 minus natural log of 2 all over 4. Now, if you remember back from Algebra 2 or Math 3 or wherever you learn the rules of logarithms, you would remember that when I subtract two logs, that is equivalent to taking the natural log, or the log, whichever log you're taking, of the quotient of these. So it would be the natural log of 14 divided by 2, or in other words, the natural log of 7. So we end up with natural log of 7 over 4 is equal to 3 over 3x plus 5. Okay. And then we're going to go ahead and cross multiply here. So we end up with 12 equals 3x plus 5 times the natural log of 7. And then solving for x, we're going to divide by natural log of 7. So we end up with 12 over the natural log of 7 equals 3x plus 5. We'll subtract 5. So we end up with 12 over natural log of 7 minus 5 equals 3x. And then we'll go ahead and divide by 3. So we end up with 12 over 3 natural log of 7 minus 5 over 3 equals x. So that's my answer. That's my final answer, and I can leave it like that. Or we can type that into our calculator and get a decimal value out of that. And as the end result, we get x equals 0.389 if we round to the nearest thousandth. So when x equals 0.389, we have a tangent line that has the same slope, the slope of the tangent line has the same slope as the slope of the secant line here. So that's our answer there. So I hope that warmed your brain up a little bit. If it takes a little bit to process this, go ahead and rewind a little bit, rewatch it if you need to. But let's get started with our lesson in antiderivatives in the next video.